First off is I work for TD Industries. They're a Texas-based full-service contractor. We do all the major trades. This year, I think we're expected to hit somewhere between the $950 million to $1 billion business, and things are very, very busy. We went through a massive technology overhaul a couple years back, and Stratus was one of those softwares along with Revit, STEMEP, and our ERP system. So we are based mostly in Dallas, but we have offices in all the other major cities in Texas, as well as Phoenix and Denver. Real quick, as a separate side note, Jake presented this slide in his presentation, and what I want to, you notice how it starts with BIM and then goes to fabricate and then tracking. At AU, I'm going to be presenting on using STEMEP with Stratus. So again, seeding some more ideas out there in terms of more opportunities that we might have that we may not have leveraged yet. So if you're going to AU, make sure and get in on that. So to modify his slide a little bit, adding EST at the beginning of that flow and how that data set is going to play into our project success. Okay. All right, so setting up the base point of diameter inches. To give credit of what I'm presenting on is not my idea. This is something that Lyle Yonda developed on how we do it at TD Industries. So I'm just presenting on the workflow that he's developed, and it's really good. I like it, so I just wanted to get it out there and share it with everybody. Diameter inch is a standard productivity metric calculated by multiplying a pipe's nominal diameter by the number of joints. So this is not, I'm not talking about the circumference, I'm just talking about if it's a 4-inch weld, then it's a 4-inch diameter, okay? But we also do this not just for welds, but we do this for no-hub joints, we do this for solder joints, we do this for, all the ways that we put two elements together. We want to know what the diameter inch is of those so that we can calculate our throughput metrics. Okay, so this is just a quick baseline of understanding and aligning on what we're talking about here, and how we have traditionally solved this problem. Years back, the TSI method was to create a joint, an ITM, and put it in your database in the services, so that when you put these two fittings together, it automatically will place that extra ITM in the model, okay? And you also have to set up your connectivity with this male-female logic, right? So it creates some extra connectivity work that you have to do in order to set this up to automate. So largely, that's the way most people do it. If they have connectors if they're trying to do diameter inch metrics, this is how they set their system up. All right. So what are the problems with this workflow? First is the service setup. It requires extra steps. So if you have multiple people who are configuring their services, they have to know that they need to add these joints, which ones to put in. So it's just more training, more learning that you have to provide. Detailers have to be aware that this element is in their model. It's hard to see. It has no length. So if you delete a couple of fittings, it's quite possible that you could have these very teeny tiny things just floating around in your model and make it very difficult to find and get rid of. There's really no coordination value to having these things in your model. They don't take up physical space. The whole point of a coordinated model is to coordinate space, right? So having them in our model doesn't really make a lot of sense. It really overcomplicates your connectivity. Connectivity is already a very complicated thing. We don't need to make it more complicated than it already is. More parts fundamentally means larger file size. So if every joint, every time you put two pieces of pipe together, you have an extra thing floating in your model, right? It's just adding to the size of your Revit model. And then from a Strata standpoint, more parts equals longer publish times. Matt shared this graph, I think last year, where he looked at the different ways, things that might affect publish times. And the overwhelming, most strong thing that affects publish times is the quantity of parts that are in the model. So if these parts are affecting my model size, they're affecting my publish times, they're making my connectivity logic overly complicated, it starts to really wonder, do we actually need them at all, okay? So the goal is, if it doesn't take up physical space, then don't model it, okay? I want the information, but it doesn't need to be in the model. I want to keep my connectivity logic as simple as possible, but I still want to calculate my diameter inches. So I want to be able to put my pipe together without those extra elements in there, okay? But still get my metrics. So what we're going to do is we're going to look at the sheet metal as our inspiration. Sheet metal, when you model in fabrication, we can get the gasket information. Well, there's gasket between those two fittings, but when you separate those fittings in fabrication, there's no teeny tiny gasket represented between those two elements, okay? So when you're setting up your connectors in fabrication for sheet metal, there's these options for, you can add an ancillary for material slip, you got drive, you can add corners and bolts, clips, gaskets, so it's very well built out on all these extra ancillary materials that you need for sheet metal. Okay, so using this as the inspiration for what we're talking about today, we want to use ancillaries to calculate joints. I don't know if everybody in here knows what ancillaries are, so I'm just going to cover it real quick. Ancillaries are not physically modeled, okay? This is just metadata that is attached to an extra part, okay? Let's see, it avoids clutter in the model, but still, right, you can get the information in there. It's rule-based, so you can set up rules when you want some ancillaries to show up, depending on the connector size or the size of the duct, right? It has flexible output, and it's centralized, it's controlled in our centralized database. If anybody not familiar with ancillaries, everybody's generally familiar with them. All right, so setting up an ancillary for joints. We want to give consistent naming, prefix or suffix for a better query. Okay, so once it comes to reporting on ancillaries, you want to have some data that is telling you that this is a joint material. Okay, this is not a real material. This is just there for reporting metrics. Use breakpoint tables for all the sizes that are needed. Okay. So for diameter inches for pipe, right, do you need it for 1/2 inch all the way up to, whatever size pipe you need. Develop codes, okay, so you're gonna need IDs so that you can create MapProd entries for each of these sizes. Add the product information into the product information editor as a decimal value. This is something that we learned once we start pushing this into Stratus. There's a size column in MapProd that is asking for size. Initially, we put size in as fractions, and when it comes to reporting on this, it just needs to be a decimal metric, okay? So setting up your ancillaries as joints. So once you've set up the ancillary, we want to apply the ancillary to the connector, okay? So when you apply it to the connector, as you put pipe together, right, that's just metadata that's inherently happening behind the scenes that no one's having to actively work on. All right, so we apply the joint ancillary material to the material drop down in the connector. So there's a screenshot of the connector dialog, and you can see I've got material highlighted there. So we're just associating the ancillary material to the connector, okay? And put it on the female side of the connectivity logic, right? So we don't want to double up on this. So if you're going to put it on a hub system or even a no hub, put it on a no hub system, you'll put this ancillary on the coupling, right? You don't want to put it on the pipe, okay? So when they come together, you'll know it's picking up from both ends, okay? All right, OLETs is a really nice benefit of this workflow. So the part of the OLET that is welded onto the main is a long-standing frustration of not being able to capture that weld because there's not a physical weld logic that gets placed there from the software standpoint. But if we're calculating our diameter inches like this, we can associate the ancillary to that connector. So setting this up, you have to assign it on the OLET to the third connector, right? And again, as you're modeling or as you're reporting on this information is just actively or passively being added to the parts. All right, you can also set up ancillary kits. I was trying to not, when I was putting this together, I was trying to not turn this into a commercial for ancillaries, but that's kind of what this ends up being. So an ancillary kit is, well, you know, if I already have a joint applied to a connector, I also might want to have other things, right, accounted for. And here's an example of, well, we've got some gas, right, being calculated for a weld. We've also got some, what was that? I can't read it. MIG wire, okay, also being totaled for that weld. So when we run a report, I can get an idea of how much gas it's going to take, how much MIG wire it's going to take to, right, fabricate this package, but I can also get my joint off the same thing. So I can just create these kits and associate the kit to the connector. So every time, right, we model, we're getting this kit on every single connector, giving me material totals and also joint totals, okay? Anybody familiar with kits or not familiar with kits? Okay. Are you asking a question or just, oh, okay. All right, so what does this look like when we get to Stratus? Stratus stores the ancillaries in a delimited format. It's not the most ideal way from a reporting standpoint for us to work with. But when you click on a part, you can see on the left side that's an example of a delimited result, right? You can see I've got a 0.75 product size and then a delimiter and then a 0.5 product size. So quantifying this from in Stratus is a little bit frustrating, and Jonathan has created some fields for us to iterate over these delimited fields and total them up. All right, so use fields to combine and total the number of diameter inches. All right, so this is the way the total from array in fields basically looks at each of the different parameters that ancillaries are stored in and gets the total from all those different fields and puts them together, and it's kind of complicated. I wish this could be done a little bit of a different way, something that makes a little bit more sense, but ultimately the math works, and you can get your diameter inches of your package through ancillaries. Okay, so this really, again, this is an attempt at not having absurd amounts of these no length joints in your model. Now, do you still model welds? Yes, you still model welds. There was I forget the company in the Northwest. I went out there, and they had set their database up in a way where the welds actually had a positive offset, and they were accounting for their weld gaps without a physical weld in there. And I thought that was a really interesting way to do it. I'm not here suggesting you do that, but it is a little bit of an eye-opening to just see that there's other ways to do the same thing in fabrication. So, and then bonus is MCAA. If you guys are familiar with, the labor metrics out of WebLem, they have a work activity method, which is labor that's associated to the joints. Okay, so how many of you are implemented on EST, MEP? Okay, that is the least implemented software from fabrication, but in my opinion, even if you're not using EST, this is still an opportunity for you to plug labor metrics into your database in a simplified way. Okay, so you can build out these ancillary joints to align with this work activity method, and then input these metrics right in fabrication. So even if you're not using EST in your pre-con department, you can still get these labor tables built out in fabrication in a reasonable way, right? And do labor projections, right, in manufacturing of how long things will take. All right. And I'm done. How fast did I go? Wow. Got lots of time. I've tried to make as many slides as I could. It's not a complicated topic. Is anybody already doing that? You're calculating your joints through ancillaries. Okay. You do labor that way? Okay. With the work activity method? Or did you kind of come up on your own?
Hard-coded the numbers that we wanted to use. Costing is harder, especially if it ends up being like less than a cent, 1 penny.
Yep.
If you're calculating like Vic Lube or emery cloth.
And that's what we from a consumable standpoint, we have a consumables costing table that we put all of that into one number. So you don't have it itemized out, because you're right, it does get quite granular. But if you know all these things total up 5 cents or whatever, 10 cents per weld or per diameter inch, right, you can apply it that way. Yep.
In your slide, you showed pipe to coupling.
Yes.
How would you set it up, pipe to pipe butt weld?
Pipe to pipe butt weld? Well, the weld still gets modeled, and the joint is applied to the weld. Okay, but when you're running your calculations on diameter inches, you're using ancillaries across the board.
So how do I apply the ancillaries to a part, to connect to A of the pipe or B of the pipe?
The weld still connects to the pipe. You got pipe and then a weld and then a pipe.
Yeah, so I'm not putting an ITM in anymore.
For the weld you are, because it takes up space.
Our shop wants to go zero length. So right now we have...
They want fitting to fitting, or I mean straight to straight.
So what I'm doing at the moment, my ITM is .001 thick.
Yeah.
So can I get rid of that?
You'd have to do a shared connector. If you had a shared connector between the pipe, you could still get half the diameter inch from one side of the pipe and half the diameter inch from the other side of the pipe. You'd have to set it up that way. I think you'd end up with, though, you'd have a system where you're never going to use welds anywhere. Okay. I would set the connector up as a shared connector and just let them connect, and then half of it comes from each side.
The butt weld, you just do a factor of 1/2. Calculate all the butt weld, all the connectors.
Well, you don't need it. No, you don't calculate it 1/2. The connector is shared, right? There's a shared option on the connector, if I'm understanding correctly.
I'll look into it.
Okay. That's an interesting workflow.
I did set up one database with no welds, where we had offset the nodes. Don't ever do that.
Don't do that?
No. No, we never do industrial, so I did that in their database, because that's what we wanted. And then, they had to do weld tracking. Or if you get different welding equipment, you gotta change your weld path. You can't just swap in a different weld joint anymore, because it's big.
Well, weld tracking is worth talking about. So if you're doing weld tracking in Stratus, you'll still track your welds against the physical weld that's in the model. Stratus has not given us the ability to track against ancillaries. That'd be a really nice improvement if they allowed us to do that, but fields are tied to parts. We can't create fields that are tied to ancillaries. So that's one of the, I think, issues with this workflow. You can't, put somebody's ID on an ancillary, unfortunately. And you can implement this while you're already running your work. This is not that complicated to configure in the database that you already have. I think the thing that is probably the most complicated is unraveling your connectivity logic to get rid of those little extra parts. That'd be the most complicated thing. Otherwise, it's just ancillary information. Pretty straightforward. Any other thoughts, comments, nasty remarks? Think it's a terrible idea? It's okay.
So for a coupling on a package, and each connector has a joint in it, like a solder coupling, they're going to solder both sides of it, but not both sides are soldered in that package. How does it, if it's tied to both connectors, it'll always read the parts in the package and the ancillaries will come from both connectors. Is that something you kind of just account for in your calculations, or is that kind of?
You're saying like if
Get it to only track the weld?
they install one half of the coupling and the other half is technically getting, then no, there's no, I can't split that up because it's associated to the coupling.
Yeah.
So manufacturing would get credit for that, and then the field would not get credit for that hookup. Yep.
One thing that I've been asked to do is take our shop hours for joints, but also have the field hours calculated. Are you guys doing any kind of stuff like that? So you know what the shop's doing compared to what the field has to do?
Our labor comes from MCAA and it's associated to the parts. We don't put it on the joints. So manufacturing has their own throughput metrics that they keep on the side of their performance on soldered, but it's not actually in fabrication. So if I was doing that, I might separate. There's an install table, there's it's called F times and E times. What is that? The fabrication rate and the erection rate, right? So if you're doing a field labor rate, you could put that on the E rate, and then your fabrication, you could put that on the F table. So that would separate the metrics into different buckets. So you could still get, some kind of labor for the fabrication and different labor for the field. If that's asking me.
Yeah, just from shop joint to field joint. That's what they're looking for.
Completely separate joints
Right.
with different labor rates on them. So your VDC would have to know this is going to be a field joint and this is going to be a shop joint, right? Okay. That complicates your BIM model for sure. Yeah. Having a feedback loop. I'm not sure how to best handle that without going through VDC. You might be able to add some kind of checkbox or something, I don't know, that adds an extra 25% or something to the shop labor. I don't know. Probably should stop talking about that because I don't know the answer. Anybody else?
I'll throw one at you.
Okay.
You went to OLEDs.
Yeah.
OLEDs typically have
then put more ancillaries on it. The same, if it's a 3/4 inch, just add 3 of them.
Okay.
Yeah. Yep. Yeah. Right. How EST is going to be helpful? So if you're not using EST, right, that's fundamental, right? I think that's probably the biggest hurdle to this process. But having EST and Stratus combined really opens up some really interesting opportunities for your project teams. It is a very different perspective. Stratus was built very shop, manufacturing oriented, and as Jake talked about all morning, they want to have this big push Stratus for the field. And so if you're estimating with EST, that is available to your project teams long before your VDC model is available. And it really becomes a question of what could your project teams do, having access to the EST models in Stratus, while VDC is bringing on the actual coordinated model. But there's a lot of data and I think a lot of opportunities that the EST model is going to provide to the project teams without giving away the whole thing. I haven't even put that presentation together yet. But that's one of those ideas that is new. In my opinion, it's probably one of the most exciting things that's happened to STMEP in a long time. And I just hope that dropping some ideas out there might spur some other thinking across the industry of what opportunities that could bring to us. Did that answer your question, Jonathan? Okay. We have one of our PMs is here, and he's already using the EST model on his project. So if you have more detailed questions about that, he can rattle off all sorts of benefits that he's found out of it. All right. If that's it, thanks for your questions. That helped me burn up another 10 minutes. And we're done. You're dismissed.